Hello, and welcome to the fifth and final of the videos in this DataMan Multi-Reader Sync series. If you have not seen the previous videos, I recommend you watch them before continuing. In this video, I will show you how to set up a 360-degree conveyor scanning application for the food and beverage industry, like the one shown here. I will highlight best practices and noteworthy strategies you can use to make your application successful. In this example application, round cereal containers are being scanned on a fast-moving conveyor by 4 DataMan 474s. The containers may be rotated in any orientation, so it is important that each one is scanned all the way around to ensure codes are found. This application uses MRS to synchronize triggering and simplify control of the system. This is a food and bev application, but the setup I will show you in this video can certainly be used in other industries and adapted to other projects, especially those with high line speeds. The first step in a good 360-degree scan setup is proper hardware selection and configuration. You can use many varieties of DataMan Reader. Because we will be using MRS, you should stay consistent between models for this application. In this video, I will be using 4 DataMan 474s. The next detail to nail down is how many readers you will need. There are no perfect answers to this question, and it will depend on many factors, including the reader model you choose, the diameter of your product, and the size and orientation of the barcode. Through some experimentation, I've outlined some guidelines. The value P in this graph is the ratio of the diameter of the product to the width of the code, measured around the product. In my experience, the larger this ratio is, the more readers you will require. This graph shows the number of readers required for ladder-oriented codes in a free-spinning 360-degree scanning application. The highlighted values are for a standard Coca-Cola can. So you would need at least 4 DataMan 474s or 374s to scan a can all the way around. For the same application, you would need at least 5 DataMan 260s or 360s. I have not experimented as much with fence-oriented codes, but as a general rule, you will need 2 or more extra readers. I expect this will be true for 2D barcodes as well. Remember, these are only guidelines. You will need to experiment with any application to tune your setup and reader count properly. What is easier to define are the proper PPM and reader positioning. For a DataMan 474 reading 1D codes in ladder orientation, you should adjust your working distance and lensing to achieve a PPM value of approximately 2. From 1.5 to 2.5 PPM, you will have the best decode times. You should check this recommended value for any reader model that you're using. To position your readers properly for a free spinning application, distribute them equally around the circle and ensure that they are pointed directly toward the center of the product. This alignment is crucial and can be the difference between a successful 4-reader application and a troubled setup requiring 5 or more. You want every object to be centered in the field of view of every reader all the way around the circle. Moving from hardware to software now, I can discover all 4 of my DataMan 474s in Setup Tool. My first step, as always, is image formation. Here, I'll just do simple DataMan tuning. Next, I'll need to configure my reader groups. I'm putting them all in a single group so they can trigger together and return a single result. I'll use continuous external triggering for each of them. Then I can easily test whether group triggering is working. Hooray, flashing lights. And I can get a good read from any of the 4 cameras. If I remove the can, I get a no read. For this setup, let's assume that we will have 5 scans per second, or a scan every 200 milliseconds. Let's also assume we only want a single capture for each trigger, regardless of the length. To make this true, I will set my acquisition interval to greater than 200 milliseconds, so I will never get a second capture on a trigger. So my currently defined timing looks like this. I have a trigger start every 200 milliseconds with a trigger end at some point in between. I have an acquisition time slightly greater than my exposure that is not repeated before the next trigger. My next timing concern is properly getting secondary camera responses. I need this to be greater than my decode time, preferably at least 10 milliseconds greater than my worst decode time, which is my no read time. So, I will set my secondary camera response to 80 milliseconds on my primary device. Now my timing chart looks like this. I have a problem, however. I don't know how long my trigger signal will be, and my secondary camera timeout won't begin until my trigger ends. So if it were to be 121 millisecond trigger signal, I wouldn't be guaranteed to return a response until after the next trigger had started. I can actively manage this timing ambiguity by using an output delay on my primary reader. I find this setting in Inputs and Outputs under its own tab. I will set the delay to 180 milliseconds from the trigger start. This will guarantee that I always return a result at exactly 180 milliseconds, regardless of whether I have a good read or a no read. If my secondary readers have not returned a result, then they are assumed to be no reads, and such a result is returned. I chose 180 milliseconds just in case the subsequent trigger signal is a little early. You can't be sure exactly how consistent a conveyor system will be. When setting output delay, you could also include shorter ones for the secondary readers, so they also always return a result, but that is not strictly necessary. If you have an encoder, you could also manage your response time with a distance delay rather than a time delay. In that case, ensure you are using DataMan firmware 6110 or newer, and use the distance-based secondary timeout. That concludes this MRS video series. Thank you very much for watching, and good luck with your setup.